This panel is focused more on, now that we have these AI agents, how we can go about with proving or verifying that their actions are as we correctly anticipate, that their behavior is as expected. We have lots of members who are part of ZK projects who have been building in this space for years as part of our panel. Maybe you can start, Jseam, a round of introductions on what you're currently working on and your role at your project.
Hi guys, I'm Jseam. So I'm working with EZKL. So we essentially do verifiable AI with zero knowledge proofs. And now we are mostly focused on DeFi applications.
Hi everyone, I'm Vikas. I work with Kite AI. I'm the head of protocol. At Kite, we are building the agentic payment blockchain. So all the payments, the guardrails around it and more, I'll talk later. So we have come up with a framework that we call as SPACE framework, which is around stablecoin, programmable trust, agentic identity, compliance, and on-chain cryptographic execution.
Hi everybody, my name is George. I lead strategic partnerships at Zero G or Zero Gravity. Zero G is building the world's largest AI L1 chain. It's EVM compatible. We have what we consider a modular decentralized AI operating system, which has three core components. The first is the fastest and cheapest decentralized storage network. The second is the fast, fully verifiably and decentralized compute network for inferencing, fine-tuning, data verification. And then we have a data availability solution, which is also the fastest and the highest throughput in the space. So we bundle all of those things, the storage, compute, and DA, into an operating system. It sits on our chain, and we're able to empower all the builders across other chains to utilize these, infrastructure to bring AI on chain. So our goal is to bridge the gap between Web 2 and Web 3 AI and make AI a public good. And the way we do that is by providing a modular architecture with hyper-optimized infrastructure.
Hi, my name is Amrit. I handle operations at Altlayer. We started off as a RAS service. We still do. We help people deploy rollups. But as a part of a broader infrastructure as a service provider, we also help people deploy agents, especially in hardware setting, where these agents generate hardware proofs that could be used on Ethereum or in other applications.
I'm wondering if each of you guys could help define what it means for these agents to have verifiable autonomy, how each of your projects are working to address that, and why it's imperative, especially at this moment right now, to consider verifiability when it comes to agents.
I guess I can start. Is everyone comfortable with math? Like, if it's okay if I go into the mathematics. So if you think of AI agents like really doing like some kind of fx input, right? So let's say a simple model is like linear regression, like mx plus c. So if you want to prove this, like how do you actually prove this? We convert this form into a ZK commitment. And so once you have it in a commitment scheme, you can then prove that this formula was calculated correctly on a given set of inputs. And that's essentially what your AI inference is doing, and that's what we are proving. So we can prove like the correctness of this formula on a verifier that you can deploy on-chain. So how the AI is being used on-chain is through this proving that this formula is calculated correctly. And that's like the gist of like inference. And now you also have to attest to the X. Like how do you attest to the inputs? There are a couple of ways. You can use state proofs, or you can use like data availability sampling, or even NPC using and like as an oracle. So those are like the few ways that you can use data in a provable manner on chain. So the next part was like the use cases or what?
Just how you would define verifiable autonomy in terms of agents, and for your case, for EZKL.
Yeah, okay. So this is essentially the gist of the mathematical problem we are dealing with. And now we can prove like this to ingredients. Now you have essentially a verifiable system that is autonomous. It's all done through mathematics, and you can audit the system in a mathematical way.
We've defined it differently from other chains. When we started building Kite, our thesis was that blockchains needs to be designed for the AI world, right? So every blockchain was being retrofit to add AI into it. So we said, how can we design a blockchain which is AI native or AI first, right, as a first class citizen? So we started breaking it down into different layers. So what we call as 3 different layers. The first layer is how do you ensure that there are enough guardrails, right? So there is something called as programmable trust. You could basically define different guardrails. What can this particular agent do? Where is this agent coming from? And then you could also write all of these things into what we call as on-chain verification, right? You can actually go and verify after the fact for now, indeed, and later on it can also be like an optimized way that this agent actually did what it's supposed to do. So there's an audit of that which is on-chain. Now, some of these things already existed in the Web2 world. So one thing that we are also adding, which is a little different for the agentic economy, is how do you define the identities, right? So we have different controls for agent. So the control of agent is at a user level. Which users could access which agents for what purpose? The access is also at an app level. Which app can call which agent? And then we also have control at session level. So if a particular session goes rogue, right, or behave in a malicious manner, only that particular session is impacted, not the entire access. So if you look at it, we really broke it down into the programmable trust part, the on-chain verification part, but also different identities. We call it hierarchical identities that we have created for the agents, apps, and at a session level.
Yeah, so from zero-G perspective, verification is really important. We already have hundreds and hundreds of projects building on our chain and are deploying AI agents that handle, sensitive data, for example, or even like real money. So like DeFi agents scouring the blockchains for yield and for good investment opportunities, for example. And so, what we had to do to create this chain to be safe for AI agents is we had to start from the ground up. And so we re-architected the entire tech stack. We started with data availability. We made it super fast, right? 50 gigabytes per second in throughput, which is super fast and great for fully on-chain AI. This allows you to verify transactions very fast. So if you look at an Ethereum transaction, 70% of your gas fee that you spend is because of the data availability. It's because of verifying that transaction. We were able to reduce that by many, many times, like 1,000 times. And so now we have super low gas fees and super fast verification. And then we talk about decentralized storage. So how can you trust an AI agent if you don't know what data it's tapping into, or you don't know what model it's using? Decentralized storage actually helps this. It has a clear on-chain provenance record of where the data came from. And if you want, you can make it visible. So you can actually see the data and you can see what version of the model it's using. And then we combine that with our compute network, where we can actually host AI models and train AI models. What you can see now is the model weights and biases, right? When you use ChatGPT, OpenAI, you don't know what model weights and biases are, right? You put a prompt in, you get a response, but you don't know what went into that training of that model. But with zero-G, because it's a fully decentralized network, there's clear transparency on the model weights and biases. And we take it a step further and we allow the community to participate in the training of the model. So whether you know it or not, you're helping OpenAI become better. You're already doing that. So why don't you actually participate in a decentralized network where we can actually track how you're making our models better and get monetized for it? And so this is a way where the community and the retail audience has ownership in the AI models. They have clear provenance of the data. There's censorship resistance because, again, it is on the blockchain, so it's really hard. It's quite immutable. And then we fully vertically integrate the entire stack, storage, data availability, compute, into the AI model. And the agent that is tapping into that model can be trusted. And then we added another component to actually help with the trust aspect of AI agents. We created a new NFT standard. It's called the ERC7857, or an intelligent NFT. And this is truly for AI agents. What we realized is that in order to prove ownership of AI agents, it's not actually easy on chain. When you create a token, it's really easy. You have contract address, you have the contract at the creator. But when you create an agent on chain, it's hard to prove who actually created it and who owns it. And so we think the best way to do that is to bundle the agent with the data and the model and put it into a framework like an NFT. And then what you can do is say anybody who owns that NFT basically owns that agent. And then what you can also do is fractionalize the NFT, which means you can fractionalize the agent itself and allow more participants to come in and own this agent. And so what we were able to do is say, hey, if you want to have access to this agent which is generating yield or revenue, and you want some revenue share components to that, just buy pieces of it itself, right? Instead of trading the ticker, right, AIXBT or these meme coins that we see with virtuals and etc., those are just representing mind share of agents. it's better, in our opinion, to own the actual agent. And so now you have a clear provenance path, you have a clear ownership path, you have the censorship resistance, and then we are also working on scalability. That's the next, focus for zero-G. And so all of these things should help fully autonomous AI agent systems to run on chain. And we're trying our best to minimize the trust aspects.
To think about verifiability, in my view, is to think the way smart contracts run on a chain like Ethereum. Or you make a call to Aave, like a flash loan kind of call, and this message that comes out of Aave goes to Uniswap in some way. Now, how does Uniswap be sure that the message that's coming in is actually correct and valid? And the way we kind of assume this, because you have this underlying base layer, which is Ethereum, that gives you that trust. So you have that trust layer, and that's why you build composability. So I think verifiability, people often say verifiability as a standalone thing, which is like, okay, here is something that I outsource to you, and you give me back a response, and I'm going to verify whether you did it correctly. Yes, but it works in only one single context where you have a remote server and you are a client and you want to verify what's coming out from the server. But that's not always the use case. There are many scenarios, as mentioned earlier in this smart contract setting, you need verifiability for composability. You cannot compose if you cannot verify. And if you look at the way agents are being built, it's quite understandable that you want to have one agent or even one model that would be good for everything. You could see that with ChatGPT, and you could see that with Anthropic and other models that are being built around. Some agents are good in certain things, or some models are good in doing certain things, and the others are good in doing something else. And so you could have a derivative where you could have one agent does something while it takes that data, whatever it creates, and feeds it to some other agent. And then again, you need this verifiability because you cannot compose without that. And then again, this composability comes in different forms. So for example, it could be a model where I'm an agent, I produce some output, and I want to give this output alongside a proof to some other agent. Or it could be a model where I produce a proof and then I send that to Ethereum, and then anyone can consume it. And so the way we do this, at least for now, initially, is to use hardware. So every agent is run, for example, in a hardware, and that hardware produces a proof as a certificate. And that certificate could be consumed on Ethereum in other contracts, in other agents directly, and they can verify this. So that's our approach for now. But again, there are technologies being built with ZK and so on that we're happy to adopt, and they're ready.
Yeah, it's great to hear all of the diverse approaches that all of these projects are taking. So on EZKL's side, you guys are more focused on proving the inference level. And then as you mentioned, Vikas, about being able to differentiate the different identities across the different layers. And then even on your side, George, you mentioned about the decentralized storage aspect that zero-G uses. And even when it comes to packaging the agent itself to an NFT, and that way you can prove not only the actions for that agent, but also the ownership aspect as well. And from you, Amrit's side, about your point with verifiability on the composability aspect too. I think those are all very important points. And for this next question, I was wondering if each of the panelists can also explain some of the potential bottlenecks that comes with verifying these agents, either on the computational intensiveness side or if there's any kinds of latency that occurs. I'm just curious, for example, for EZKL, you guys are focused a lot on proving the inference level, but are we ready? Do we still have a few more steps before we can actually reach to the stage where we're able to prove the end-to-end behavior of agents? And then also from the other panelists, any other kinds of strategies or tooling that you guys are using to help with these bottlenecks?
What do you mean by end-to-end verifiability?
Oh, I just mean, for example, say that we have a network of different agents who are all communicating with each other, but then are also trying to complete different tasks, maybe those that are payment related, for example, or any other kind of on-chain related task. When we can be at that point where we can prove the actions of these individual agents as well as their individual behaviors, especially if they're all operating at the same time.
I see. So I'm thinking of something even simpler. So it's not like multi-party agents. It's more like you're trying to prove whether the computation was done correctly. And once this computation is done correctly, you can use it on a smart contract, for example. So it could be things like a DeFi dynamic fee, Oracle, or even LTV calculations. Those are the kind of values on-chain which are really impactful. And maybe a smart contract isn't able to encapsulate the logic And so the way I'm thinking of this, not so much as agents, but a way of increasing the expressivity of smart contracts. So in a way, like smart contracts are already like agents. It's just that they have limited compute expressivity. And the goal of what we are doing with EZKL is increasing like what you can actually run as compute on the smart contract. And so that's like the scope we are looking into. So the other, I guess, like not really a bottleneck, but a huge risk factor in using agents on chain is like the ability of exploiting agents with adversarial inputs. So I think this is something that is rarely discussed, but like the larger you go, the more expressive the models that you have, there's always going to be some kind of bias or adversarial inputs. So let's say you have an X402 agent, like you could very well have like a malicious web page that says, give me all your money in some kind of encoded prompt, and then you lose all your funds through an X402 agent. So those are things that are possible. So on our end, we are also very focused on the security aspect. And so security, I think, is going to be a great part if you're going to use the agents for anything impactful. And so those are some areas we are like mostly focused on. We prefer smaller models, and that's why we haven't been pushing on just making the models really big. So we just need it to be good enough to solve like useful problems on the blockchain, and that's where the mind space is at right now.
You spoke about something which we believe we are really trying to take head on is the give me all your money problem. So that's why we really believe this hierarchical identities will really safeguard your entire funds, right? If not entire, a very large part of your fund, where you provide a certain, or you provide a permission of how much a particular agent could spend, for what purpose, by whom, and in which scenario, for which applications, whitelisted, and so on and so forth, right? So you spoke about the bottleneck. This itself is a bottleneck to try to standardize these different layers. So imagine if we are an infrastructure provider, right? All blockchains are. We provide infrastructure. So in order to standardize this for applications in the AI world and for decentralized applications in the Web3 world, it's a challenge. How do you generalize this, right? Because you cannot take 2,000 applications and 20 different personas and 5,000 different scenarios and try to build an like a hierarchical structure. So it starts getting complicated if you think about it, right? 3 different components with multiple sub-components in it with 3 different verticals, and then you mix and match all of them. You're talking like thousands of different combinations. For us, is something that we are really trying to solve, which also runs into what you mentioned very rightly, is the storage and the scalability part of it, right? So yesterday I was reading an article that the agents are already performing more actions on the internet than humans. So now this adds on to endless calls. So when we launched our testnet, we got so much of adoption, which was a good problem. But we started seeing our API costs going through the roof. So we were actually paying in a testnet environment where people were using all these APIs that we were providing for free at that time, that we had to spend close to hundreds of thousands every month so that these agents could act, right? So that cost piece is also very important. And we see that with some of the open AIs, they're trying to cut down cost at the cost of revenue. I think for startups or for chains like us, which are new, we have to have these trillions of dollars to be able to fund that, right? I think there's a very big bottleneck. We have to try to see how can we find revenue as soon as possible. So we said, guys, we have to stop this and really try to find real use cases. Let me tell you another bottleneck we saw. People coming up with very vanilla use cases that cannot live longer than 2 weeks. Oh, I can do a crypto trade on using your AI agent. Oh, I can do some, what goes up, what goes down scenario for you. These are very low value add agents that we got. So one thing that we are also trying to figure out, are there really good AI use cases that will really benefit the end users in the long run so that they can stick to it? If you look at ourselves, we are paying for 2 or 3 GPTs only in the world. Rest of the AIs are just living off their own, right? We don't even pay for that. Even GPT is not trying to give free access to millions of people. So I think finding an agent which is beneficial and a value add, where they can ask for revenue and we can also take a commission of it, that's another bottleneck that we see day-to-day aspects. Another very major topic is the security around these agents, right? Again, in the agentic world, people are trying to retrofit how security worked in the human internet. which is going to be very different than how it is in the agentic economy. That's a topic for some other day. But these are some of the problems that we are seeing. And when you're early in a journey like this, trying to be, at least try to say that you're the first AI native blockchain, every new step that we take is first time for us, and try to solve that nobody else has solved. Security, access, scalability, storage, identities, all of them are bottlenecks for us that we are trying to solve one after the other.
So verification-wise, there's a few things. Our compute network, as I mentioned, does inferencing and fine-tuning decentralized and fully verifiably. So what do you mean by verification of inference? There's slow and fast verification. Slow is kind of the way that the conversation that we're talking about, which is ZK. And ZK is almost 100x slower than the other alternative, which is TEEs. And so TEEs are trusted execution environments. This is where actually majority of the zero-G AI workloads are actually being computed. They're working within TEEs. And we have our partners at Fala for that, and a few more partners are going to be announced. And then this is the benefit of TEEs is super fast, right? But it's not highest grade verification compared to ZK. And so there are industries such as the Department of Defense, high frequency trading, things that deal with really sensitive data and really high value things like the U.S. military. And for them, they're willing to, go with something more expensive and slower, such as ZK, to verify a lot of the inferencing and a lot of the AI workloads. And so our marketplace and our compute network follows kind of like a hybrid approach where you can choose, right? As a builder, you can choose if you want to use the TEE aspect or if you want to use the ZK ML or ZK proofs. It's up to you as a builder. But in the future, we feel that we can actually merge the two options, and actually you should be able to choose both options, right? And so for more time-sensitive requests that you need, like for example, an LLM where every second delay is critical, you can use the TEEs, and then for military and for these more sensitive things, you can use ZK. And so this was actually a really interesting learning from us that ZK is so expensive, but we realized that anyway we should give both options to the teams. One more aspect we built on for verification is we created these things called AI alignment nodes. And these AI alignment nodes kind of act like an on-chain policeman, which actually help verify the data that's being parsed through the chain. And so it actually checks through storage nodes, validators, data availability nodes, and it checks for malicious data injection. And this is, again, another important thing. If you say there's a model hosted on a zero-G network, how can you verify that it's not an inaccurate model or it's not drifting? And so AI alignment nodes was some of the things that we created. We had a large sale for this. We raised around $35 million. It was like 100,000 nodes were sold. This was last year. And so we decentralized and distributed the network. And so now it's not zero-G's alignment nodes that are determining whether the transactions and the models are safe. It's the community, right? We have over 15,000 people who have purchased nodes. They run these nodes and they're helping to secure the network and to make sure our network is verifiably secure.
If you ask around on crypto Twitter or elsewhere, what's one agent that they know, that probably would be IXBT, which is basically a wrapper on ChatGPT with a token slapped on top of it. And then you have similar things like Goat and so on, which basically is some fancy lore that somehow you get attracted to as a cult. And I think this is a problem that I think industry has faced for a long time, which is because there are all sorts of weird incentives. People don't end up building things that actually are people want, and you could see that we discussed earlier. You discussed earlier that people see where you see things, people are excited about it for maybe a week, and then basically it dies off. And I think we have to fundamentally think a little bit more deeper around building for the longer term, right? Building something, agents or otherwise, that hangs around, that something that would survive the test of time. And that would also test some of our internal infrastructures that we're building. So imagine, for example, take MetaMask or Phantom or any of the wallets like that. They could very easily test all the agent capabilities and all the infrastructure that supports those agents by simply having a little integration around them. So for example, imagine just having a simple bridge, or having a simple, agent that basically takes your tokens and deploys in different, pools for your USDC yield and so on. That could very easily test whether the agents that we are building actually makes any sense whatsoever. Sadly, we are not there yet. But I think what's missing is basically one, partner, one system that has distribution in crypto and activate one agent that people want to use or people use it. In the same way, previously, people, if you wanted to bridge assets from one chain to the other, you go to a chain or you go to a bridge web page, and then basically you pick your source chain, your destination, then you do all of these things manually. Now all of that is basically hinted. You don't see it, but you actually magically you see your USDC appear natively on that chain, destination chain of choice. So I think we are yet to see an agent that we would use, because we need it, rather than just being thrown at your face.
Yeah, there seems to be a common theme here where we need to find that particular use case or particular application that can drive this kind of long-term value for these agents. Just as a last question before we close today's panel, just on top of that, are there any types of particular use cases that you think could drive this long-term value, especially as it comes to in the future when we need to verify the actions for these agents on these applications? Are there any that you see as up and coming or any that you're excited about?
The thinking that we have, like our smart contracts are technically agents by essentially how we are describing it. So that's essentially, I think, like the purpose of smart contracts in the first place. So I think the most impactful use case, just from a computational standpoint, is just increasing what your smart contracts can do. Because if you really think about it, like how you have programmed a smart contract since 2017, since 2018 has barely changed. And so the reason being is that there's only so many things you can do on a smart contract. I think this is going to be impactful in the way you would think about smart contracts. Like how can you improve the amount of things that you can express in a safe and verifiable way? And that I think is basically the thing that can last. It's a new foundational technique on how you can actually build smart contracts. And this is where we are approaching this product from.
I believe, and that's also what we are pushing a lot of our partners that we are working with, is that can we build reputation or trust score around agents that people bring to you, right? I think that is something that we are lacking. Very similar to what you mentioned. You have these smart contracts that you can trust because it is verified by OpenZeppelin, right? You can go quickly check, okay, can I trust this? Okay, trusted, audited, you can go ahead with it. Agents that we are deploying or that we are using currently on our systems or on our infrastructure, we are blindly installing them or running them, right? I've done that myself a lot of times. How do you build a system around it, like a agent reputation system or agent trust score system, that if you're using it, it uses the smart contract within it is verifiable, right? That there's verifiability coming from a legit source like zero gravity storage system or something coming from Altlayer, that you say that I can really trust this agent because it checks box A, box B, box C, and box D, and it scores 4 out of 5, like the rating system. Now you can actually trust that agent. I think that is something that I believe also from a Kite perspective, the infrastructure part of it needs to be ready before people get tricked into running things that can actually bring more damage than more value to their ecosystem.
Yeah, I think the most interesting thing that we're seeing now, I mean, we were able to launch our mainnet a month and a half ago. It was very successful along with the token. But what we're looking at now is actual use cases that will excite our community. We have a very large community at ZeroG, and they're just looking and dying for things to do that are exciting with AI and AI agents and things like that. So one of the products that we're coming out with relatively soon is ZeroGPT. It's going to be basically an LLM interface, which is, you can think of it like the front end for the entire blockchain, for our entire chain. And you can just use natural language to interact with any of the dApps on ZeroG. And so, for example, if you say, I want to swap $100 for ZeroG, you just type it in and it will find the smartest route for you. It'll find the best DEX, decentralized exchange. It'll handle all the custody and everything for you. And then it'll make that swap executed for you and give you the ZeroG tokens. And that's just for a trade. Like, we're going to do it for gaming. We're going to have it for model training. We can do a lot of cool things with this LLM. And we think this will actually empower a lot of users to actually save time in their life. Right? When we go on chain, we have 100 apps that we may be interacting with if you're a power user. Maybe it's only 5 apps if you're an amateur user. But the point is, you're interacting with different instances across different chains, for example. We think unifying all of that using an LLM and using AI agents is the best way to do it. The AI agents should be in the background. It shouldn't be the front end in the way that you have to actually go and interact with an agent directly. We think that multiple agents, hundreds of agents should be coordinating together in a multi-agent framework and executing tasks for you. So if you say, here's my calendar, here's the different events I have to go to, here's the budget, you should just be able to put all that in a prompt. It's literally going to coordinate multiple agents together to take the money, take your calendar, take the travel agencies to actually book these, the hotels and the flights, and then execute all of that. So the multi-agent framework working in the background is something that we're super excited about. We think that is the killer use case of AI agents, right? I don't think we've seen that yet, and it's really difficult to execute. But because we laid the groundwork over the past several years of building out the zero-G chain to support these type of multi-agent systems, we're pretty confident that we'll eventually get it right, and we're super excited for the community to come and try it out.
One use case that I'm personally very excited about is around prediction market use cases. Of course, because it's the hottest thing, in the market right now. And the reason is, if you look at most of the prediction market out there, including Gulshi and Polymarket, the top ones, they all kind of permissioned in the sense that the internal team decides which market to launch and how to settle that market. So the rules are defined by the team. Now imagine a world where you want to have permissionless market. So anyone comes up and creates a market for that. The question is like, how do you then decide how that market settles? And this is where even now today, when Polymarket sets those rules, there are always, discussions and debates around, no, that was not true. This was not. The idea is like, if you launch a permissionless prediction market, or, Polymarket decides to do so at some point, then you need someone that decides, one, what would the rules for settlement would be. And then how do you, so how do you settle these markets, first of all? And the simplest way, in my view, is the way real world works. Today, if you go and watch a football match, there's a referee that decides. You may not disagree with him all the time, but he's there, he has certain rules to follow, and he goes and makes his decision. So the idea is like, I think you could actually build a permissionless prediction market with agents deciding what the settlement rules should be, and if there's a disagreement, and if enough people go and challenge, then there could be a third, maybe using a different model that comes and says, no, this is what it should be. So I think this is something that, given the fact that prediction markets are quite hot, I'm really excited about someone building a permissionless prediction market using agents.
Yeah, absolutely. And it's very exciting to come to these use cases where we can expect these fully autonomous agents to interact, and even if there's disputes or any kind of disagreement there for more additional parties to come in to try to settle. So very exciting that we're coming to a future where we can anticipate use cases with just these autonomous agents interacting on the network. And thank you so much for all of our panelists for joining. It's very interesting to see all of the different ways and methods in which all of these projects are dealing with verifiability, from the hierarchical identities to the decentralized compute, and even with the smart contracts perspective that you mentioned. And Amrit, with your some of your perspectives, especially on the incentive alignment as well, I think are all very critical.